Okay. My name is Ryosuke Yajima from the University of Tokyo. Today, I'd like to talk about our construction planning and robot integration system and its implementation in our educational program. Japan's construction industry faces significant challenges with low productivity and labor shortages. To solve these issues, the Ministry of Land, Infrastructure, Transportation and Tourism in Japan has implemented a policy called I-construction. One of the key points of the I-construction is to introduce new information, communication, and robotics technologies into construction site and to fully automate construction site. Therefore, it is essential for civil ICT and robotics engineers to collaborate across their disciplines. Okay. Our laboratory has been advancing research, development, and educational activities to contribute to this I-construction. As one of the educational activities, we developed a civil engineering and robotics integrated educational program. In this program, students can learn about construction planning and automation using model construction robots in a simulated earthwork construction site. Since 2021, this 4-day intensive course has been held annually. In 2022, fully automated environment was prepared for the students by robotizing all excavators and dump trucks. However, some issues were revealed. The main issue was that the information in the developed construction plans could not be used directly for the operation of the model construction robots. In this study, to address this issue, we developed a system linking construction planning and construction robots and introduced it into our educational program. This is the outline of our educational program. The task is to excavate soil and transport it from one side to other side. There are 3 main parts. First, students will learn how to create construction plans under site constraints, and how to measure productivity and calculate cycle time and costs. Second, students will learn how to control robots and how to automate construction works by using small construction robots, excavator and dump trucks. Third, students create an original construction plan and program for automated construction. Finally, each group performs a simulated construction and compete on time, quality, and cost and automation level. As I mentioned, the main issue was that the information in the developed construction plan could not be used directly for the operation of the model construction robots. In previous method, equipment layout planning in the construction planning was done on PowerPoint file. Therefore, in order to use the target positions or running paths in the plan for dump truck control, it is necessary to manually input them into Python scripts. To address this, we've introduced a web application for the construction planning and an API for data access. The web application makes it easy to plan equipment layouts, and the API provides access to the planned position or path in the web application. By developing programs that interface with this API, we can establish a direct link between construction plans and model construction robots. For the actual system, RCDE and Service Hub were used. The RCDE is a prototype of a common data platform for data and system collaboration in the construction phase, which developed by the University of Tokyo and the Japan Federation of Construction Contractors. We use the feature to visualize 3D models and point clouds stored in this system for equipment layout planning. A service hub is a prototype of an API collaborative platform that connects the RCD and various devices or applications. This system was demonstrated in the educational program of last year. This is the entire prepared system. The RCD and the service hub were built on AWS, and the model construction robots were built using ROS2, a robot operating system 2. First, students access RCD from a browser, and the 3D point cloud of the simulated construction site is displayed on the 3D viewer. Second, for the layout planning, 3D models of marker representing robot's position and path, such as spheres or cone, placed at arbitrary positions on the point cloud. Third, the program to control the robots send API requests to the service hub as needed and receive the marker position information in the RCD as a response. Finally, the received information is used for the robot's path following. The implementation of Python script and the use of the obtained information were not directly instructed for the students, and they were left to the students. There were differences in usage, but the developed system worked as intended, and the construction planning, it can be said that the construction planning and model construction robots were integrated. For example, this group develops a program that first performed API access when the program ran, obtained the position information of a group of markers based on the RCD, and used it as a path for the dump trucks. This is the conclusion. In this study, we developed a system that links construction planning and construction robots for our educational program. And the developed system worked as intended, basically. In the future, by addressing these issues, we will create an environment where students can focus more on creating new ideas for the future construction. Sorry, that's all. Thank you.